So question 10 says, use the given 0 to find the remaining zeros of the function. So we have x to the third minus 2x squared minus 11x plus 52, and one of the zeros is -4. So one of the things we can do is using our calculator, we have an apps button. So if we use the apps button located here, see my little mouse moving on the calculator. Under there, we want to choose number 7, display SMALT2. So like polynomial simulator of some sort, SMLT2. So if we click on number 7 there, notice how number 1 is this polynomial root finder. So we want to choose that. Yours may look different than mine, but what we can do is put this polynomial into the calculator. It is a degree 3, so we need to change the order to 3. Hit enter. So hit enter. How do we do that again? Hit enter again. There we go. Now, instead of dealing with real, we need to change this to a plus bi. So hit enter. It'll change that over. Everything else we'll just let play out. So if we hit next, yours may look different. So I want to put the coefficient of the x cubed in. It's 01. Mine actually asks for the plus sign. It's actually going to be a minus sign. So I changed that with a minus. Put a 2 in. So I should have a minus 2x squared. I also have a minus, again, hit enter, 11, hit enter, plus, and then that looks good, hit enter, and then 52. So what you're looking for, again, you may have like a sub 3, a sub 2, a sub 1, and a sub 0. A sub 3 stands for the coefficient of x cubed. A sub 2 stands for the coefficient of x squared. A sub 1 stands for the coefficient of x, and a sub 0 would be the constant if that's the way yours is playing out. So I have it in. So notice I have this little solve button above graph. So if I hit the graph button, it'll actually do this menu up here. So notice how it gives me my 3 zeros, the -4, and then it gives me this 3 minus 2i and this 3 plus 2i. So that's really all I need to do for that one. Now, we also, if you wanted to, you could use synthetic division. I could put the -4 as my R value. And then I have a 1 as a coefficient, a -2, a -11, and then the 52. Give myself a little bit of space. So remember, in synthetic division, the 1 can come on down. So then I go -4 times 1, which is -4. We add the -2 and the -4 and get a -6. We multiply the -4 times the -6 and get a positive 24. A -11 plus a 24 would be 13. And then -4 times 13. So we have to quit this here. So number 6, quit that. All right, so -4 times 13. That gives me a -52. And -52 and 52 gives me a remainder of 0, which is what we want. So remember, what we just did is divided out a factor using x plus 4. We divided into the polynomial and got a new polynomial, which would be 1 degree less than we have. So if it's x cubed up there, this is going to be x squared. So this is going to be x squared minus 6x plus 13. So what we need to do now is factor this, or solve for this, if you will, to find the zeros. So to find the zeros, we're going to set that equal to 0. But notice that the factors, there's no factors of 13 that are going to give me this -6. So I am going to have to use the quadratic formula. So A is going to equal 1, B is going to equal this -6, and the C is going to equal this 13. So X is going to equal then the opposite of -6 would be 6. plus or minus the square root of. So I have a negative 6 squared minus 4 times a, which is 1, times c, which is 13. And then we're going to divide all this by 2 times a. 2 times 1 would just be 2, though. So the only math I really need to do is the what's inside the radical, which is called the discriminant. It kind of tells you what kind of roots we have. So in parentheses, we have this negative 6 squared, which is 36, minus 4 times 1 times 13, which is going to be a negative 52. And 36 take away negative 52 is kind of what we're dealing with. And that would be a negative 16. So x is going to equal then the 6 plus or minus the square root of negative 16 divided by 2. Now, remember that square root of 16 represents an imaginary number. So we have 6 plus or minus, the negative comes out as an I, and the square root of 16 is 4, so that comes out as 4i divided by 2. So then we just separate this as 2 pieces, 6 over 2 plus or minus 4i over 2. Notice that each one of those can be divided by 2. 2 goes into 6 3 times, 2 goes into 4 twice, so 3 plus or minus 2i, such that we do get the same roots as we came up with up here, the 3 plus 2i and the 3 minus 2i. So we have the same solutions using the synthetic division and the quadratic formula. And that's Rene Descartes back in the day. But for us, we also have technology that we can take advantage of in this situation.